When we look at these graphs, if I draw my vertical lines, I can draw this one vertical line that crosses two of these red points or red dots. So that means this is not a function. This next one again, if I graph this vertical line, I have two intersections, so it's also not a function. I have on the following one, on number 7, even 3 intersections, so again it's not a function. And the last one, if I draw a vertical line, it crosses in 2 places. Again, it's not a function. The next question says there is a set of ordered pairs and we need to decide if it is a function. What I'm checking first is, do I have the same x coordinate in any of the ordered pairs? If I don't have the same x coordinate in any of the ordered pairs, then this is going to be a function. So the first one is -4, then -3, then -2 and -1. So none of the x coordinates repeat. Therefore, for every input there is one output. So this is going to be a function. The input is -4, -3, -2, -1, and my output is 1, 2, 5, and 1. So again, for each one of the inputs, there is exactly one output. A linear function is written in function notation if the output is represented by f of x or g of x and the input is represented by x. F of x or g of x is nothing else but basically y. So it's just a different notation of the similar type of equation, the y equals mx plus b, but y is replaced by f of x. So in this next question, f of x is 2x plus 4, which means the same thing as y equals 2x plus 4. So we are given some function values for x and we need to figure out f of x, what f of x will give us. So if we substitute in -4 for x, we have f of x equals 2 times -4, which is -8, plus 4 is -4. So my first function value, f of -4, is -4. My next function value, if I substitute in -2, will be 2 times -2 is -4 plus 4 is 0. The next function value, if I substitute in 0, I will get 2 times 0 is 0, so the output will be 4. If I substitute in 2, my output is 8, and if I substitute in 4, my output is 12. So I'm just going to also fill it in here. F of 2 is 8 and f of 4 is 12. All these are giving me the ordered pairs, what you can see in this table on the left. So now we need to graph these ordered pairs. So the first one is -4, -4. The next one is -2, 0. The next one is 0, 4. Then we have 2 and 8. And this is the last one we can graph in my grid. So all I have to do is connect them with a straight line. And here is my function. In this next slide, we are given some ordered pairs in a table of values, and we need to figure out if they are functions or not. If they are functions, we have to give the domain and the range. So in this first table, again, I'm going to check, do I have any of the same two x values? If I check that, I see that I have a -1 and a -1. Then the next thing I need to check, do they have the same y? This one has a 1 and this one has a 0. Therefore, these are two different y's, so this is not a function. In the next problem, if I look at my x's, I have all different x's. So that means this is going to be a function. So the domain of this function is 3, 5, 7, 9, and 10. And since I don't have enough room on the bottom, I will put the range up here, and the range is just 0. So we look at the last problem. We have an 11, a 2, 0, 33, and 5. None of these x values are the same. Therefore, this one is also a function. So if I list my domain is 11, 2, 0, 33, and 5. And again, the range I will write up here, and that's 1, 22, 0, 3, and 55. In this slide, we are asked to evaluate the function for several values. We need to evaluate for x equals 2, 0, and x equals -2. So I'm going to place those numbers in my table, 2, 0, -2. And on the right-hand side, I'm going to find the values for them. So f of 2 will equal to -3 times 2 plus 1, which is -6 minus 1, -5. F of 0 is -3 times 0 plus 1, which will just give me 1. And f of -2, -3 times -2 plus 1. So the first part is going to give me 6, and then plus 1 will give me 7. And the second part of the question is asking us for the domain. The domain is 2, 0, -2, and the range is -5, 1, and 7. In this last slide, we are giving you your homework answers, so please check your homework before you turn it in. Thank you.